Alrighty, it's time to talk about box and whisker plots or box plots. This was a quick lesson, so we're going to try to give you some review. A box and whisker plot looks like what you see here on the screen. There's the lower extreme, then the bottom of the box is the lower quartile, then the median is right in the middle, then the upper quartile is right at the top of the box, and then you have your upper extreme. Now, what you need to know is to find your interquartile range, you would take the Q3 amount and subtract the Q1 amount. To find your range, you take the upper extreme and subtract the lower extreme. Okay, but something else I want to make sure you know is that in this lower quartile, there is 25% of all the data points. In this second quartile here, there's another 25% of all the data points. In this third quartile, there's another 25%. And finally, in the upper quartile is the last 25%. Sometimes you get questions like that on the SOL where you'll need to know that 25% of the data is in each one of those sections. All right. So if we talk about box and whisker plots, okay, the first thing you need to do is put your numbers in ascending order, which means smallest to largest. These are already there. 2, 4, 7, 7, 10, 14, and 22. Your upper extreme is 22. Lower extreme is 2. To get your range, you take 22 minus 2 and get 20. Your median, because if you look at it, you've got 3 pieces of data here and 3 here. So the one right in the middle is your median, 7. The lower quartile is the median of this bottom numbers, and your upper quartile is the median of your top numbers. And to find your interquartile range, you subtract those two numbers. So 14 minus 4 is 10. Let's see if we can do some problems. Again, if there are things you don't understand, watch the videos again or watch them in slow motion or ask us questions. We're glad to help. It says here which 2 plots, we have plot A, plot B, and plot C, appear to have the same value for the interquartile range. So that means we need to know this number and this one, so we can get that. This number and this one, and of course this number and this one, to see which 2 appear to have the same value. Well, if I look down, this looks like a 32 right here, if I go all the way down to the line. And then this looks like a 27. Okay, now this one here looks like a 33, and this looks like a, I guess it's a 28. This here is a 31, and that here, gosh, that looks like a 27.5 maybe. So to find the interquartile range, we're just going to do some subtraction. 32 minus 27 is 5. Let's go to the next one. We got 33 minus 28 is also 5. I think we've got our answer. And finally, we've got 31 minus 27.5, which is 3.5. So which 2 appear to have the same interquartile range? That would be A and B. All right, let's look at the next one. It says which data set has more elements with a value of 11 or greater. Well, first of all, let's find 11. And I'm going to take 11 and I'm going to draw a line straight up from 11. Okay? And it wants to know which one has more elements above that. Well, I can tell you that this has 2 sections. 1, 2. And they're both worth 25%. So this has 50% of elements are 11 or greater. Now let's look at the bottom plot. 1, 2, 3 sections, which 25 times 3 is 75%. So which one has more elements above 11? That would be plot B. Okay? All right, let's look at the next one. We've got several things to read here. It says each of these box and whisker plots represents a data set with 10 distinct elements. So there's 10 pieces of data in each one. which statements about them are true. All right, well, let's see what the first one says. It says the interquartile range of plot A is greater than the interquartile range of plot B. Well, I'm going to actually type plot A, and I'm going to do the interquartile range. It starts here, which is at 19, and down here at 8. So I'm going to put 19 minus 8. So that interquartile range is 11. Then I'm going to type plot B. I do that just to help myself stay organized. The top of plot B is at 21 and the bottom is at 11. So I'm going to do 21 minus 11, which is 10. So the interquartile range of A is greater than that of B. That is true. So we're going to put a T right there because that's what we're looking for. Now, it says the range of both are equal. Range means upper extreme, subtract lower extreme. So for plot A and B, the upper extremes are both 23. So I'm going to put 23 minus and 23 minus. Then the lower extreme for A and B are both 6. This is very interesting. Okay, so they're both 17. The range of both plots are equal. Again, that is true. They are. Alrighty, now let's see what the next one says. 25% of the data in plot A is less than or equal to 8. Well, here's 8, and here's 8. Is 25% of the data in plot A less than or equal to 8? That is true. That is also true. Because one section is 25%. Now this says 75% of the data in plot B is greater than or equal to 21. Well, here's 21. Greater than or equal to is this section here, which is 25. And this says 75%. So that is the one out of all of them that is false. Okay? If you have any questions, make sure to let us know. All right?